Welcome back to this class where we are talking about the different types of inorganic materials. So, now we will see one most important material is your carbon material. So, what are the different types of carbon which will be utilized for industrial use? As we all know that people can have the consideration that carbon, okay, this carbon is the basic material for giving you all the different types of organic molecules. But when you have the organic molecules, which is not only the simple carbon, you can have also hydrogen, you can have oxygen, you can have the nitrogen. But when we talk the carbon, the inorganic carbon material which will be useful for industrial use is that the different forms or the different modifications. What we know, these different modifications we know from our early childhood that the carbon is available in the diamond form, in the graphite form, and in recent time we know that the carbon can be obtained in the corresponding C60, C70 form, which we all know that they are the corresponding Buckminster fullerenes. So, these are the different modifications of the different forms basically, but now we will see in this particular class that what are the different types of all these carbons are useful industrially, because the inorganic chemistry based industries always produce large amount of carbon, the carbon black say. But the special types of carbon starting from that carbon as the filler material to that of your active ingredients as the active catalyst. So, the two varieties basically will be looking for the special types of carbon basically and the different types of graphites, because we know that huge use of graphite is that of the electrode material. So, if we want to make the graphites, the different types of graphite, because nowadays in the era of the nanomaterials we make all the nanoparticles. So, the carbon nanoparticles, the carbon different types of material from that, and like that of your C60 or C70, the graphite can also be converted to the graphene material, because the graphite we all know they are C6 layers. So, the continuous C6 layers you can have on the graphite, and if we can remove one such layer from that graphite surface, we get the corresponding graphene material. So, people are working on that graphene material also very much to have some good utilization and good application in terms of its corresponding research or industrial application. So, industry, the corresponding inorganic industry, the inorganic chemistry industry will be devoted to make the new forms of these graphites which can be available cheaply, and how from that graphite people can make the graphene or any other very special type or the sophisticated material out of these. So, right now from the very basic material we let us see how we can have the different types of carbon material and the graphite material. So, one such is that the pyrolysis, we know that how we burn a corresponding wood material or the wood substance. So, if we burn the wood material or the wood substance by pyrolysis, we all know that the pyrolysis can give you the corresponding end product at the charcoal. So, other material can also come out, which we all know that the pyroligneous acid. The pyroligneous acid, that means the liquid form of that during that particular charring or the burning process can be taken out, and from some chemicals we can identify from there, and we can isolate all those chemicals out of this. But presently what we will be looking for is the product as the burning product of the wood material or any other starting material, that we will see that what are the material we can use for making the pyrolytic graphite is one form, and another form is your pyrolytic graphite, because the pyrolysis can be directed to get the graphite material in your hand. So, another particular form or the specialized form. So, produced by the corresponding pyrolysis is the thermal decomposition of gaseous or vaporized carbon containing compounds. So, different carbon containing compounds, it can be your simple wood material or the corresponding any other type of husks material. So, any carbon containing material can be burned such that only the carbon part is leaving behind, other material will be burned as oxides, and taking the proper precautions that we do not want to burn the carbon as carbon monoxide or carbon dioxide, because we want to leave it as carbon itself. So, these pyrolysis reactions which take place at a particular temperature which is very high also, depending upon your starting material or the raw material or the feedstock. what material we are utilizing for getting this particular type of carbon is important. So, a range from 800 to 3000 degrees centigrade is important for both in the gas phase and on the substrate surface. So, if you go for the corresponding gas phase condition, that means if you burn something which can leave behind your carbon and your carbon surface, the powder form of the carbon is getting activated. That will give rise to the variety which is known as your activated carbon. So, at this point you try to remember that what particular temperature will be useful such that you can leave behind with the carbon product from any other very cheaply available raw material for burning process. So, this can be utilized for impregnating porous synthetic graphite. So, the pyrolysis reaction basically can be available for getting some graphite, because the graphite we have told you that you have the continuous 6 membered C6 rings. So, continuous layers of that So6 rings will give you the graphite, and you have the interplanar connectivity through the pi interactions. So, those layers we can have, and definitely those layers basically you can have either the planar size or the longitudinal part, you can have the pores. So, basically if large number of pores are there and the pores are free to absorb something, you get the corresponding porous synthetic graphite through this particular process. Then it can be utilized for application in which the highest resistance to erosion or oxidation is required, that is guiding the tubes for fuel rods in nuclear reactors. So, those carbon varieties basically can be utilized, as we have seen that for making the synthetic graphite, that can also be utilized for making the fuel rods in nuclear reactors. So, is very high temperature withstand should be there, and it should also be very highly stable. So, the tubes should be there guiding tubes basically for fuel rods in nuclear reactors. We use those graphite material. So, graphite, as I told you, that it can be also be a very useful electrode material for our simple application of dry cells. We all know that the central rod is your graphite rod. So, making of those graphites for making those dry cell batteries, one of the utilization is your inorganic carbon material as the graphite rod. So, if you have then further application of this material that it can have, because the carbon is very innocent material, it will not harm anything to anywhere. So, if biologically it is compatible, that means it can have excellent biocompatibility, then one variety, that means isotropic variety of your pyrolytic carbon articles or carbon material can be used in health sciences for making some useful material based on the carbon. So, the carbon is the material which can be used for your heart flaps or heart valves. So, artificially when we try to make these heart flaps or heart valves, the carbon can be your active ingredient for some along with some other material. So, carbon can be your active ingredient for making those, because it has very excellent biocompatibility, and also in making some other prosthetic devices which we can put inside our body. So, if some part, some organ or some functioning thing went wrong, we can substitute those by using this particular carbon material for implantation. Now, we see two varieties of carbon which are known as your glassy carbon and foamed carbon. We know that the glassy carbon is well known to us, we know as GC. GC is a useful electrode material. So, not the graphite electrode, but is also the glassy carbon electrode. For some electrochemical measurements, we quite often we do in the laboratory for cyclic voltammetric measurements, we use GCE, like your platinum electrode or other platinum wire electrode or the platinum disc electrode. We can also use simply the GCE, the glassy carbon electrode also, and that carbon in the foamed form is known as the foamed carbon, and not very high temperature, only 1000 degrees centigrade is fine. So, at high temperature pyrolysis can produce at a temperature of 1000 degree these two varieties of carbon. So, what are those starting materials? Basically not anything carbon containing material or carbonaceous material can be utilized for making this material, but some polymer materials. So, scrap polymer materials which we throw away basically. So, the burning of the polymer material, the plastics you see, the utilization, very useful utilization of those plastic material can be done by making or getting that particular thing in the carbon form. So, if you have some used thermosetting polymers, because thermosetting polymers we know that they are very useful and we can use those thermosetting polymers for different purposes, different household use or any other uses. So, throwaway thermosetting polymers can be burned, is the burning process. Very simple process for this industrial process is the burning process. So, the raw material which is used for that making those carbon material is very cheap one. Then polymers rendered non-melting by chemical treatment. So, some of these polymers basically, because otherwise if it is in the molten condition, is very difficult to burn that and the pyrolysis also can be hampered. So, this particular variety, the first variety, the glassy carbon variety is non-graphitizable modification. That means we are not able to convert that means it is not being able to convert it to a graphite form. So, we cannot have the graphite modification out of this procedure. So, it is a different procedure for getting your glassy carbon. So, the form what we are getting having a small crystallized. So, it is basically the very small particles are there. So, the positioning of those particles not that of your graphite type, giving you the glassy form. As a glassy, that is basically a sintered form. So, it is basically a sintered form of carbon with a different structure which has having a ribbon structure. Since it has a different structure compared to your graphite or diamond or C60 and the crystallites are there with a maximum diameter of those crystallites at only 10 nanometer, you get a glassy carbon variety out of that. And then that strong intertwining of the carbon ribbons. So, the corresponding binding of those carbon ribbons. So, if it is initially you have the ribbon thing and then intertwining of those ribbons is basically very much similar to that of your formation of the polymer coil. It is not that polymer coil, because the polymer is completely different, it is the carbon now. So, one carbon is the attachment of all the carbon particles there, giving you a corresponding ribbon structure, and ribbon structure then particular winding of this thing can give you the corresponding polymer coil type structure. Where we apply now like other varieties, that application of the glassy carbon now like that of your graphite, because we want to know very quickly that what are the materials we can have, how we can apply that material for some useful purpose and the applications. Otherwise, the charm, the benefit of this particular course will not be there. We should know very well that how we can utilize those material, what is your product and how the products can be applied for some useful purposes. So, this application for the glassy carbon is that for the different types of laboratory analytical procedures, because that activated charcoal or any other thing can use, and as I told you that GCE we can use in making the corresponding electrode for simply cyclic voltammetric measurements. So, which is one of the electrode for your CV measurements, the cyclic voltammetric measurements we use glassy carbon. Then metallurgical industry is also getting benefited out of that. Then semiconductor industry also. Semiconductor industry can also use the glassy carbon or the foamed carbon for their application. Then the different medical sciences, if we have some use of those glassy carbon material, then also the aerospace industry, because this material can be utilized for making the aerospace material for making some aeroplanes or any other models or any other thing. So, it is a component of the corresponding aeroplane or the airship or the airspace material. Then the second variety is your foamed carbon. That is also once again like that of your glassy carbon, is non-graphitizable. So, that non-graphitizable material can have the corresponding cell structure like that of your polymer foam and is remains intact upon careful carbonization. So, the initial structure of the polymer foam is retained, and during that particular careful carbonization, because the corresponding remaining part is the carbon particles or the carbon structure, and the corresponding density is lower than 0.1 gram per centimeter cube can be achieved and can be obtained. And now we see the second variety, that means the foamed carbon variety, and that foamed carbon variety how we can utilize for different applications. First, like that of your glassy carbon is still your metallurgical industry, then for utilization in foundry technology, then one most important thing is the fire protection, because if you have this carbon and the carbon based material, if you use for a shielding material, that the fire protection shielding material, even for if you can use that carbon cloth. So, that carbon cloth type of material can be useful, because you cannot burn it, because you require very high temperature to burn that carbon material. Even for the smaller particles, the nanoparticles of carbon can also be useful if you are not burning it. If it is catches fire at a particular temperature, then it is wrong. Otherwise, it can also be very much useful for fire protection. Then for production of the catalyst, because the surface, the heterogeneous solid state surface of the carbon particles in the foam formed can also be useful itself as a catalyst surface. Some cracking, some decomposition can be achieved on that particular surface, because that particular surface is completely different. If it is a heated surface or chemically soaked surface, that can show different reactivity pattern. And also that particular surface, the foamed carbon surface, can also be utilized for your catalyst support. So, catalyst can cover that particular surface and can be utilized, and that particular surface should be inert one. So, the inert foam based carbon based foamed carbon based surface can be utilized for your catalyst support also. Then different types of industrial laboratory applications. So, carbon can be your material for making different laboratory items or different laboratory identifications for that particular purpose. Then we move to the form, another form basically known as carbon black now. What is that carbon black? Because large number of companies in our country also we handle that making of this carbon black as the carbon powder. So, anything, any black material or any black component or black surface, always we try to think all the time that whether it is made up of carbon or not, because large number of areas we are utilized for utilization of that particular carbon black. How we use as carbon black is the black color also. So, this carbon black we will find somewhere in our future classes. That can also be a very useful pigment material, inorganic pigment material based on carbon black itself only. So, it is like that of your pyrolusite, manganese dioxide, which is also a black powder. So, if you have a black powder and if you want to use that as a pigment or a paint, we can use that simply that particular black as your carbon black. So, how industrially we can produce that black carbon, that we see now. So, the particle size, so we fix the corresponding particle size from 5 to 500 nanometer. So, this 500 nanometers, obviously they are a little bit of bigger type, but the surface characteristics will be different when you go to the bigger sizes of those particles. So, range from 5 to 500 nanometer primary carbon black particles. We are not modifying anything, that is why we are not modifying it to a secondary form, is the primary one. Whatever we produce by charring, by burning, by pyrolysis, we take that as your starting material for your carbon black. So, it is consist of deformed or twisted graphite layers. What are these carbon black? So, these carbon blacks by definition also you should try to remember nicely. If somebody asks you what is carbon black, why the name is such, that is carbon black, what type of material it is. It is basically is not of regular structure of graphite. So, you have the deformed structure when you know that the structure, the actual form, the regular form of graphite is a layer structure. So, if the layer structure is not there, the layer structure is broken, we will have the corresponding deformed structure. And if there is some twisting, so winding of the thing, so twisted form of the layer. So, layer is getting twisted. So, the twisted form of that particular graphite layer, which are spherically oriented round a growth center. So, is a small center is there, and if your winding is that, the winding of the deformed graphite material is there, such that you get a small particle. So, depending upon the nature of how many layers you have, you will end up with a particle size of 5 to 500 nanometer. So, that is the most important part of it, that how you go for the deformed and the twisted form of the graphite layer through a center or the core or the nucleating point from which your carbon black is being formed. So, this is the corresponding example that is very much is well known, everybody should know that. Either you open up a textbook or you go to the internet site or the wiki page, you should know what should be the material. And by looking at the material, if your expert eyes are well trained, you should able to detect it as okay, this is your carbon black particle, not any other black material like that of your manganese dioxide, pyrrolosite or any other mineral type of material. So, it is carbon black, because if you take it in the hand also, your weight is a very light one, you can consider it as the corresponding carbon black, because what we use from our laboratory use also from our school days, the activated charcoal for decolorizing some material in the sugar industry also. The charcoal or the carbon black or the charcoal black is utilized for getting a colorless syrup of the sugar, the molasses. So, this particular carbon black, what you can have, the extent of the individual layers. So, one layers after another you have strongly, but particularly near the surface can amount to several thousand nanometers. So, if you have from 5 to 500 nanometer, then it can reach up to several thousand of nanometers in both the spatial directions. So, you can have the change in the different spatial directions, and you can have bigger sizes of those particles for some special use or the special purpose application. So, these layers, basically the layers of these deformed graphite layers can extend from one growth center to the other. So, what we are talking about, one particular growth center, it can move from one growth center to the other, and those two centers basically or more than two centers can now aggregate. So, this aggregation basically can give rise to a chain structure or the coil structure. So, basically starting from the graphite layer, the deformed graphite form, then twisting and then coiling. So, all these things will be there within these particles of this carbon black. So, that is why they have very useful application for their different use. So, we go for pyrolysis for the production in presence of oxygen. So, we use oxygen, and in presence of oxygen we try to burn it. So, what we get basically the product what we will be getting over there is the corresponding black carbon black. We will be utilizing furnace. So, that is why it is a furnace black process. So, furnace black process will be utilized for getting that particular carbon black by blowing feedstock oil, because oil we try to burn it also, that is another carbon based organic compound into high temperature gases, which gives basically high yield and allows wide control over its properties. Why we are burning oil? So, feedstock oil, any cheap quality oil can be utilized like that of your burning of the polymer material. So, oil burning can give you a control on the particle size or the structure. It is not random, it is not erratic also. So, a particular type of size. So, if we want to get a particle size of 50 nanometer or 60 nanometer by this particular process, if once the process is standardized, because standardization of that procedure is important to get a particle size repeatedly. So, reproducibility, that particular procedure is standardized when we consider that okay, by closing your eyes you go for that particular process, you will be able to get that product, the same product, same particle size and the same structure. For the different types of application, one such good application is in the rubber industry. As we all know that all the car tires to elephant tires to all the different forms of tires is there, and those tires, the color of those tires are black. Why they are black? Why you are not having a red tire or a white tire? If you want to make a white tire, you have to add the corresponding rubber can be fixed with the zinc oxide, and zinc oxide is a pretty costly one and it will not have other qualities. So, the rubber technology, the rubber industry will be very much dependent on getting this particular carbon black material, because the carbon black, once we use it as the corresponding electrode material, and that electrode material we know that it has the corresponding electrical conduction, that is why it is used as a electrode. So, the electrical conduction, your thermal conduction, all will be useful when a car tire is rotating, is heated up, and when it is there in the ground surface, you have the corresponding connectivity with the road. So, that particular temperature can be dissipated if you have a very conducting material. So, addition of those carbon particles within the rubber material, whether you have a synthetic rubber material or a natural rubber material, under the category what we study as the polymer chemistry or the polymer science basically. So, this particular carbon can go for the reinforcement, that means the strength of that particular rubber material is getting changed. The properties are also changing, the thermal conductivity, the electrical conductivity, if we consider all these things, the properties are changing to ultimately to coloring. Why your tires are black? That is why I am asking. So, ultimately to coloring, that is why all are in black in color. So, the carbon black raw materials, what we will be looking for, that what sort of carbon black material what you have prepared. So, you can have a very high carbon is to hydrogen ratio, such that not much of the hydrogen is there, that means hydrocarbons. We all know that methane, which is a CH4, which is a hydrocarbon basically. So, you have one carbon, 4 hydrogens. So, carbon is to hydrogen ratio is pretty high, that is why your hydrocarbon we do not have. We cannot make that particular one, you can have it, you can use that particular methane as the feedstock, only thing that you have to remove the corresponding hydrogens available on the carbon. So, if you have a high carbon is to hydrogen ratio for that, that will be a most useful one as your carbon black material. Then pore point, where you can have the different points of the different porous thing is there. Then viscosity, the density, the low asphalt content. So, asphalt amount of asphalt should be less, low sulfur content also, that can degrade your material characteristics of the carbon, and very low alkali metal content, that means the sodium and potassium if you have as the contaminant, it should be removed from there, because you have from the starting material the sodium and the potassium in your hand. So, once you get that basically that thing, you go for the temperature to the pyrolysis. So, the pyrolysis is being achieved at a very high temperature, not close to 1000, it is close to 2000 sometime, it is from 1200 to 1800 degrees centigrade. So, high temperature burning of the raw material is achieved starting from 1200 to 1800. And when we utilize this basically the reaction, then once you burn it, everything is finished and certain time is allowed for that burning process. The reaction is then quenched with water spray. So, we will utilize as water spray is basically being utilized for washing also, for the washing purpose from there also, and a temperature of say 500 to 800 degrees centigrade. So, water temperature can also be very high, and then ultimately further cooling, that means it is a stepwise cooling. Suddenly we are not going for a chilled condition. That means if you have a temperature of 1200 to 1800 degrees centigrade, then suddenly if we go to the room temperature, that we are not allowing. Before that, at high temperature condition in the range of 800 to 500 basically, the range basically upper range is 800 and lower range is 500. In that particular range of temperature is useful for water washing. Basically, then putting water basically, so the no further reaction can take place at that particular temperature. So, basically always we call it as a quenching of the thermal reaction. And then some heat exchanger, that means it can take further amount of heat, and for useful purpose also, that heat exchangers what we use, that if we want to use some boiler attached to that heat exchanger, so the boiler water can be heated up for some useful purpose. So, we should not lose the heat which is available with that particular material. So, heat exchangers are there which can cool further to 250 degrees centigrade. So, in the presence of those heat exchangers, the temperature of those furnace black material is reached to 250 degrees centigrade, and ultimately it is conveyed and it is processed, and then ultimately it reaches the corresponding room temperature. So, that basically gives us the idea that how furnace black can work for the production of your corresponding carbon black. So, in your next class we will just consider what are the utilization of these things, that means how they can be separated out from these and how they are utilized for the different useful purposes. Okay. Thank you very much.